This is exam 2 on reactions. It's question 1 on the exam, which comes from the 2000 AP exam, question number 3. The first part, part A, says calculate the mass percent of carbon in the hydrated form. So basically we need to figure out by mass how much is carbon compared to everything else. So there's 2 carbons, each carbon is 12, and I have to find the molar mass of the whole thing. So looking at this, 3 waters, that's 18 for each water. There's 4 O's, that's 16 each. 2 C's, that's 12 each. And BE, gonna have to look up. BE is 9. And grab a calculator, and all of those together. Clearly I didn't have my calculator prepared, which I should have. Let's see, 3 times 18, that's 54. 4 times 16, 64, that's 24, that's 9, all together. $151, and my 2 carbons are 24 by mass. So if I do 24 divided by 151 times 100, that'll give me 15.9% by mass carbon. Now if I look at part B, it says if 3.21 grams of it is heated, calculate the mass of the solid form. So basically I'm getting rid of the water part. So I have BeC2O4 times 3H2O goes to BeC2O4 plus 3H2O. So I'm getting rid of the water when I do this. So I have 3.21 grams of hydrate. So the one with the water attached. And I simply want to find out the mass of the BE formed. I know they're in a 1-to-1 ratio, so I have 1 mole of each, which will be helpful. So if I set up my stoichiometry, I'm going to write grams of the hydrate just so I don't have to rewrite the whole thing. 1 mole of the hydrate. And the hydrate is this one is the anhydrate. So I've got a 1-to-1 mole of ratio of the hydrate to the anhydrate. And then I need the molar mass. So if I look at this, I've got to find the molar mass of each. Well, I know the molar mass of the hydrate is 151, and I know that all I got to do to find the molar mass of the anhydrate is to remove the 54, which comes from the water. So if I take 151 and subtract 54, I get 97. So now it just becomes a simple stoichiometry problem. So 3.21 times 97 divided by 151, and I get 1.998, so I would call that 2.00 grams of BeC2O4 are formed.